In one of the districts of Jiangsu province, a group of engineers and workers began what seemed to be a routine task, clearing the bed of a small river for a future transportation interchange. The machinery was operating as usual until an excavator suddenly struck a dense concrete slab that extended deep into the riverbed. The initial assumption was that it was an old drainage system, but the more they dug, the more it became clear that they had uncovered something much larger in scale. Beneath a layer of silt and clay lay a meticulously engineered concrete structure that stretched for hundreds of feet. There was no publicity, no signs, and no public access. It turned out to be a fragment of an underwater tunnel connecting two districts across the river, the existence of which local residents had no idea about. China doesn't just build quickly, it builds covertly, and sometimes even the builders themselves don't know how deep the system they're working on actually goes. There are dozens of such cases across the country. In places where it seems that everything has long been explored and built up, engineering marvels can be hidden underground, wonders that exist nowhere else in the world. China is not limited to just the surface. It develops every dimension, upward, outward, and downward. And if it needs to build a transportation hub underwater, it does so. And sometimes to bring such an idea to life, you have to go even further. For example, completely remove from the map an object that had existed for thousands of years. Guizhou province is known for its karst landscapes and green hills. But one day, a perfectly flat platform suddenly appeared where one of the mountains used to be. The locals were stunned. The massif that had stood here for decades had vanished. The reason was the construction of a new transportation corridor, where every extra bend in the route would mean a loss of time, fuel, and money. Chinese engineers decided it was easier to cut through the mountain than to build a tunnel or a viaduct. Meticulous work went on for months. First, layers of soil were removed, then the bedrock. Everything that was extracted was processed. The rock fragments were used to build roads, embankments, and concrete slabs. Millions of cubic feet of earth were moved, the mountain was gone, and in its place appeared new logistics. This project became a symbol of China's engineering resolve, a nation that does not shy away from the scale of a challenge. For the sake of an efficient transportation network, it is ready to move the earth, literally. But what is truly astonishing is not only that China is capable of moving mountains, but that it knows how to look beneath them. And beneath rivers as well. After all, if you can erase a mountain, why not drill through the bed of one of Asia's mightiest rivers? The Yangtze River is not just a waterway. It is a turbulent, powerful current several miles wide, with unpredictable flows and sediment deposits that change the riverbed every season. But even that did not stop China from the idea of building a transport tunnel beneath it. In the mid-2000s, work began under Wuhan that would later be featured in engineering textbooks. First, a geological survey of more than 200 boreholes was conducted. Then the most difficult part began, the tunneling. At a depth of several hundred feet beneath the riverbed, under immense pressure, drilling machines advanced foot by foot. Each section of the future tunnel was prefabricated, delivered to the site, and submerged to the riverbed at a precisely calculated time. The ventilation, lighting, drainage, and emergency exit systems were all designed to withstand maximum loads. Beneath layers of water and silt, trains sped through the tunnel at over 200 miles per hour, and no one standing on the shore suspected that the 1,000th train was passing right beneath their feet. But this technology found another use as well. Not just for transportation. It became the foundation for the creation of entire systems, hidden, multi-level, and completely autonomous. And one day, these systems stopped being just infrastructure. They became part of the cities. In the centers of Guangzhou, Shanghai, Beijing, and other megacities, if you look a little deeper, a second level of the city is revealed. Down there, it's not just the subway. There are streets, parking lots, shops, warehouses, substations, and even offices. All of this was built from scratch specifically to relieve surface-level congestion and to ensure the city's resilience to extreme loads. Guangzhou is considered one of the leaders in underground urbanism. In the Tianhe district, you can walk through underground corridors from the subway station to a dozen shopping malls without ever coming up to the surface. Everything is interconnected: logistics, power supply, and drainage. Where an ordinary person sees only a sidewalk, there are entire transportation and utility arteries running underneath. The engineering solutions include dedicated ventilation systems, backup power, and water supply. This means that such underground complexes can operate autonomously in case of emergencies or blockades. They are designed not only as part of the city, but as its backup copy. But even such systems have a vulnerability: water. China has solved this problem in a way that no one else has before. And their answer is a mechanism capable of dealing with the power of water on the scale of a megacity. Shenzhen is a city that in just 3 decades has grown from a fishing village into a financial center while also being a high-risk zone: seasonal typhoons, torrential rains, and rising sea levels. The answer to this threat is hidden beneath the streets in the form of a powerful pumping station built with the latest technology. It can be compared to an underground ocean, only one that is controlled. When heavy rains begin, dozens of sensors throughout the city instantly transmit data to the control system. Pumps are activated, which pump water into reservoirs hidden deep underground. These reservoirs can hold millions of gallons while remaining invisible to city residents. After the storm, the water is filtered and returned to safe bodies of water. This way, the city stays dry even when torrents pour down from the sky. This project is not just a form of protection, it's an active infrastructure that works faster than the elements. And yet, water doesn't always come from above. Sometimes China's engineering marvels reach such heights that it's frightening even to look down. In the southwest of China, in the provinces of Sichuan and Yunnan, the landscape resembles scenes from science fiction movies. Mountains, canyons, valleys. All of it is traversed by incredible bridges hanging over chasms thousands of feet high. One of them, the Beipanjiang Bridge, is situated at such an altitude that from a car's cabin, when you look down, you can't see the bottom of the gorge, only clouds. These bridges are not just beautiful structures, they are vital for connecting remote regions. Without them, the journey between 2 points could take 10 hours. With them, it takes 30 minutes. China is betting not on detours but on a straight line. If an abyss stands in the way, they literally build a bridge over it. The construction of each of these bridges is an engineering feat in itself. The cables holding up the spans reach hundreds of feet in length and the anchoring systems go deep into the rock. The builders work at altitudes where the air becomes thin and any mistake can cost a life. All of this is done to create the logistics of the future. And yet, when the road meets not an abyss but a mountain range, China chooses a different path. It goes straight through. The Tibetan Plateau is one of the most inhospitable places on the planet. The air here is a third thinner than on the plains. The temperature can drop below zero even in summer. And yet, one of the highest railway lines in the world passes through these lands, the Qinghai-Tibet Railway. This is not just a railway, it is a complex of engineering solutions that made it possible to connect Lhasa with the rest of China. The main challenges: permafrost, lack of oxygen, and seismic activity. To prevent the rails from shifting when the ground thaws, they were installed on special concrete supports, and the ballast was made from special materials that dissipate heat. The trains running on this line are equipped with an oxygen supply system. Inside the carriages, the air pressure is like that in an airplane. Train drivers undergo special acclimatization before starting their routes. The bridges and tunnels along the railway are built to withstand earthquakes of up to 8 on the Richter scale. This railway is not just a way to reach Tibet, it is a statement of engineering excellence. But when it comes to water, China acts no less ambitiously. Sometimes he prefers not to go around the pond or under it, he decides to stop it. The Three Gorges project on the Yangtze River is one of the most monumental engineering undertakings in human history. The massive dam, over a mile long and nearly 900 feet high, is capable of holding back water flows comparable to 10 Niagara Falls. This is not just a dam, it is an energy and environmental mechanism that affects millions of people. Construction took more than 10 years. Hundreds of villages had to be relocated, millions of residents resettled, and the ecosystem of an entire region altered. But the result is the most powerful hydroelectric power station in the world, supplying energy to millions of homes and industrial facilities. The dam itself is made up of concrete sections, each weighing thousands of tons. Inside it are kilometers of tunnels, pumps, and sluices. It regulates the river's flow, prevents floods, and ensures navigability. Its power is so great that its effects are felt hundreds of miles downstream. But even such a giant is only part of China's water management strategy. After all, sometimes to ensure the survival of some regions, others have to be deprived of water. China has embarked on the largest water transfer project in history. Not everywhere that China wants to build a city has land available. Given dense development and a growing population, the government decided to make use of water surfaces. This led to projects for creating residential neighborhoods directly on the water, on platforms, pontoons, and artificial islands. In the city of Wuhan, an entire district has been built on a lake. Here, residential buildings, offices, and parks, all the structures are built with the aquatic environment in mind. The foundations are designed to withstand fluctuations in water levels, and the sewage and water supply systems are engineered to avoid polluting the reservoir. In Shanghai and Hong Kong, projects are underway to create new land by reclamation. Construction is carried out using special sand and gravel mixtures reinforced with geotextile. These islands are stable, durable, and can be planned more effectively than dense urban environments. Living on water is not just an architectural whim, it is a way to expand city boundaries without destroying nature on land. And yet, when it comes to redistributing water on a national scale, China reaches a level where even geographical concepts begin to shift. The South North Project is the largest water diversion project in history. Its goal is to take water from the abundant rivers in the south of the country and deliver it to the arid regions in the north, including Beijing and Tianjin. This is not a single canal, but 3 massive routes with a total length of over 2,000 miles. To implement the project, it was necessary to build not just canals, but also aqueducts, tunnels under mountains, pumping stations, and reservoir lakes. One of these tunnels runs beneath the Yellow River and stretches for dozens of miles. Essentially, it is an underwater river inside a pipe. The system is automated. Sensors monitor water quality, pressure, and leaks. Everything that once depended on nature is now under the control of engineers. Thanks to the project, water supply has been restored in the northern provinces, agriculture has been revived, and dependence on wells has been reduced. And this is not the end yet. China continues to expand its water diversion network, because if you can move a river, you can also rethink the very concept of water resources. When it comes to subways, most people imagine the usual tunnels beneath city streets. But in China, the metro has been built even in places where most countries would have abandoned the idea, under rivers, beneath bays, and through the most challenging geological conditions. And all of this with accuracy down to the foot. In the city of Shanghai, for example, one of the metro lines crosses the mighty Huangpu River right beneath its bed. The builders use shield tunneling technology, in which a massive boring machine carves a path under the water while simultaneously laying concrete rings, forming a perfectly sealed tunnel. Inside, trains travel at speeds of over 50 miles per hour without the slightest vibration or noise. But most importantly, safety. Each underwater section has an autonomous monitoring system. If there is a leak, ground shift, or even a sudden pressure spike anywhere, the system automatically sends a signal and the movement is halted. Everything is designed to last for decades to come. Underwater subways are no longer a rarity, but an everyday reality in China. But to lay such routes, you need equipment capable of operating at the limit. And such machines have long since become a reality here. On construction sites in China, you can see equipment that amazes even the most experienced engineers. Huge drilling complexes, hundreds of feet long, look like mechanical monsters. They don't just drill, they dig, reinforce, pour concrete, and seal. All in a single cycle. One such machine is the ultra-heavy TBM, or tunnel boring machine, used for constructing subways and underwater tunnels. It is so massive that its assembly and launch take several months. Inside, dozens of operators, engineers, and technicians monitor parameters in real time. There are machines designed solely for tunneling through permafrost. Others are under rivers. Still others are made for seismically active zones. Each one is the result of decades of engineering development and multi-million-dollar investments. China is betting on machinery that replaces entire crews and operates where humans are powerless. Such machines require a constant supply of materials. And this is where a system comes into play that is hard to even imagine. It delivers concrete to where it is needed deep underground. On the outskirts of Chongqing, one of the most unusual concrete plants in the world is in operation. It is called the Concrete Monster. It's not just a plant, but an entire underground complex connected to dozens of construction sites through tunnels. It operates around the clock, delivering concrete through pipelines directly to the required location, deep underground, underwater, or through solid rock. Its output is millions of cubic feet per month. This makes it possible to build without stops, without interruptions, and without outside interference. The concrete arrives at the worksite already at the right consistency, with precisely calculated additives, at the required temperature, and with the correct setting time. Engineers are proud of this system. It allows them to minimize transportation costs, eliminate delays, and improve quality. This is the conveyor of the future, the concrete pulse of the mega project, without which not a single next-generation construction site would be possible. But even such a precise system must take into account a factor that cannot be predicted: the elements. Water, which can arrive suddenly and destroy everything in seconds. In the city of Shenzhen, a unique storm protection system operates, a hidden trap capable of absorbing torrents of water in just minutes. It is an underground network of reservoirs connected to storm drains throughout the city. When it starts to rain, the water instantly goes underground without lingering on the surface. But it's not just about the reservoirs. The entire system is managed by an intelligent platform that receives data from weather stations, satellites, and street sensors. It predicts where the downpour will go and reallocates resources in advance, opening sluice gates in some places, increasing pump power in others, and activating emergency protocols elsewhere. This is not just a sewage system, it's a living system that adapts to the climate in real time. Thanks to it, even during a hurricane, the city can keep functioning, the subway operates, the streets aren't flooded, and equipment doesn't come to a halt. However, all of this is only possible if there is space beneath the metropolis. And if there isn't any, it is created beneath the busiest districts, in places where no one would suspect. In the central districts of Beijing and Shanghai, beneath multi-lane highways and skyscrapers, there are warehouses hidden, not ordinary ones, but high-tech storage facilities that operate completely autonomously. There are no people inside, only robots. They receive commands via wireless networks, move cargo, sort, pack, and deliver it upstairs through vertical shafts. These warehouses serve not only for store logistics, They work with pharmacies, supermarkets, and delivery services. Thanks to this, it is possible to reduce the load on the roads, speed up deliveries, and free up valuable ground-level space. Cargo is moved through underground corridors faster than by trucks stuck in traffic jams. The system is organized so that any point in the city can be supplied within half an hour. For emergency situations, reserves of water, medicine, and food are provided, which can be activated instantly. This is the invisible infrastructure, without which a metropolis could not function at its pace. But even these tunnels are far from the limit. After all, Chinese engineers are already going even deeper, to where a completely different level of planning begins. You might think the subway is already deep enough. But in China, things are done differently. Beneath the subway lines in the largest metropolises, new levels are being designed and already built, even deeper, even more ambitious. These are not just technical rooms. They are fully fledged infrastructure floors that will house everything from transport hubs to data centers. In Shanghai, for example, projects have already begun where warehouses, server parking lots, and even mini-factories are located beneath metro stations. This saves space, protects critical facilities from external threats, and creates a multi-level security system. Moreover, some of these levels are designed for temporary accommodation of personnel in case of disasters. The depth of such facilities can reach more than 200 feet. Given the complex geology, proximity to water, and seismic activity, this requires an entirely new school of engineering. Everything must be stable, self-sufficient, and safe. And while underground levels used to be built only in megacities, today such solutions are being implemented even in provincial centers. But such structures are needed not only for development. In some regions, they are becoming a weapon against nature itself. Southwest China is prone to landslides, while the eastern coast is regularly hit by typhoons. The northwest is a zone of seismic activity. All of this is not just a theoretical risk, but a real threat to millions of residents. China has chosen not the path of defense, but of active counteraction. In mountainous areas, underground shelters are being built to accommodate thousands of people. They are constructed near villages and connected to local water supply and communication systems. During an earthquake, people can descend there in a matter of minutes. In some areas, these shelters are equipped with automatic airlocks and air filtration systems. On the coasts, where a storm front can displace entire neighborhoods, embankment platforms are being built, artificial elevations with underground rooms capable of withstanding the impact of a wave. Beneath them are warehouses, pumping stations, and generators. This is not just protection, it is a way to make the elements controllable. And yet, amid all this technological grandeur, there are projects that are hardly ever mentioned, those that are hidden not only underground but also beneath a veil of silence. There are places on the map of China where access for outsiders is restricted. There are no tourists there, no filming, no news. But satellite images reveal strange anomalies, new roads, power line extensions, and the movement of heavy machinery. These are signs of something massive being built. According to independent sources, in one of the country's interior regions, a facility is being constructed that could change the approach to logistics across all of Asia. It is quite possible that we are talking about an underground transportation hub with multi-level infrastructure designed for decades ahead. Such facilities are not created for short-term gain. These are investments in the future, in strategic autonomy, in independence from weather, military, and geopolitical factors. China is working with a 50 or even 100-year horizon in mind. This is both frightening and awe-inspiring at the same time. And if you think that everything has already been built, you're in for a surprise, because the plans emerging on the horizon are far more ambitious than anything that has come before. Government documents, leaks from international forums, and publications in engineering journals all point to one thing: China is not stopping. Hundreds of projects are planned through the middle of the 21st century, from new canals to underground cities. Among them are the second phase of the South-North project, the construction of a deep tunnel beneath Tibet, and underground high-speed highways connecting megacities while bypassing surface developments. There are also plans to create autonomous underground agro-cities, where food will be grown independently of the climate. Enormous attention is being paid to ecology. New projects are required to be energy independent, have zero emissions, and be equipped with complete water recycling systems. This is infrastructure designed with survival under any conditions in mind. And here the main question arises: why? The answer lies in strategy. China is not just building roads, tunnels, and dams. It is creating a new model of the state, self-sufficient, protected, and resilient to the challenges of the times. In this model, space is used to the fullest. The surface is for living, while the underground is for logistics, energy, production, and security. Each mega project is a brick in the foundation of national stability. And it's also a signal to the world. The future belongs to those who are not afraid to dig deeper. Literally. A country that can move mountains, drill through rivers, and tame the elements is not just developing, it is resetting the rules of the game and doing so quietly beneath our feet. While we look at the surface, it is already shaping the future deep below.